This tutorial is about the constant rate of change. So the definition of this is a rate that describes how one quantity changes in relation to another quantity. Right? And so we put it as this, as a formula, and you'll see that this looks familiar, y over x. But that triangle means change. So we want to find the change in y and put it over the change in x. And the change means the difference. So how does that work? Well, all right, let's take a look here at what we've been given. We've got ounces over pounds, okay? Remember, on a graph, not chart, right? Table going this way, x is on top, y is on the bottom, okay? And what I'm going to do is I'm going to pick two values, okay? I'm going to do these two in the middle. So the change in y, so what's 2 minus 1? 1. Over the change in x, 32 minus 16, 16. Okay, so this is our constant rate of change. Now, if I were to put numbers in place, if I were to rewrite this as y is equal to 1/16, because I found my constant of change, rate of change. Okay, so y is equal to 1/16 x. If I were to actually do, let's just pick x as 80. I'm going to put it over 1. And then you get 80 over 16. 80 divided by 16 is 5. And there's your y. Okay. All right. So what does all this mean? Let's see. We need to see if this relationship and this relationship, are they proportional? Okay. So we need to find the constant rate of change. So I will do the change in y over the change in x. I'm going to choose those two. Okay. So change in y. So remember, when the tables are written like this, x is here, y is here. Change in y, 300 minus 150 is 150. Change in x, 2 minus 1 is 1. So my rate of change is 150. Okay. Does that work all the way throughout? Can I take 150 times each of these values of x and get this value of y? 150 times 3 is 450. 150 times 4 is 600. So yes, this is proportional. Okay, what does that look like when we put it on a graph? Okay, same information here. So if I graph this information using the table to come up with my ordered pairs, 1 and 150, 2 and 300, 3 and 450, 4 and 600. Okay, so I'm going to take my little straight edge here, and I will do the best I can, connect them. And look at that. It makes a straight line, goes through the origin, which is a proportional relationship. And we also call that being linear because it creates a straight line. Okay. All right. Going back over here. What about this relationship? We have the time in minutes and the water used in gallons. Okay. So let's choose 2. I'll go with those 2. So we're going to do change in y over the change in x. Change in y, 25 minus 10 is 15. Change in x is 2. So that means 7.5. Okay, so if I take 7.5 times 6, I can already tell you that's not going to give me 40. 30, 42, 45. Huh, look at that. If I take 2 times 7.5, that's not 10. 2 times 7.5 is 15. 4 times 7.5 is not 25. So is this proportional? No. Okay, the constant rate of change, there is no constant. Yes, I found one, but that's because I used numbers next to each other like this, and I just found something that worked, but that does not hold true throughout like it does for this one. Well, what does that look like on a graph? Okay, same information. I'm going to do 2 and 10, 4 and 25, 6 and 40, 8 and 45. Does that create a straight line? That answer is no. Okay, so I'm not even going to try to connect them. When they're all over like this, it is called nonlinear because it is not proportional. All right, I hope this helps.